for this ACM Tech Talk. This webcast is part of ACM's commitment to lifelong learning and professional development, serving a global membership of computing professionals and students. I'm Rahul Pandita, a staff researcher at GitHub Next. I worked on many GitHub Next projects, but previously of note, I led Copilot Voice project, a GitHub Next exploration that allowed developers to leverage their speech to interact with their IDE. Copilot Voice later inspired GitHub Copilot Chat and VS Code speech extension, which you can download on VS Code Marketplace today. Currently, I worked on Copilot Workspace project, which Eddie is also leading. In particular, I lead the effort around Copilot Workspace runtime interaction to aid in verification and validation of agent output. For those of you who may be unfamiliar with ACM or what it has to offer, here is some more information. ACM offers educational and professional development resources that bolster skills and enhance career opportunities. You can see some of the highlights on your screen. ACM provides access to ACM Digital Library, the world's most comprehensive database of computing literature. Leading publications and global conferences that draw top experts on a broad spectrum of computing topics. Support for education and research, including curriculum development, teacher training, the ACM Turing and ACM Prize in Computing Awards. And the ACM Code of Ethics, a collection of principles and guidelines designed to help computing professionals make ethically responsible decisions in professional practice. Before we get started, we would like to quickly mention a few housekeeping items shown on the slide in front of you. If you have questions at any time, please type them in using Zoom's question and answer button. We'll organize the question as Eddie speaks and try to get to as many as possible. The session is being recorded and will be archived. You'll receive an email notification when it becomes available. And check learning.acm.org for updates on this and other upcoming webcasts. At the end of the presentation, you'll see a survey open on your screen. Please do take a minute to fill it out and help us improve our tech talks. All right. Today's presentation is lessons learned from building GitHub Copilots with Eddie Aftandilian. Eddie is a principal researcher at GitHub Next, GitHub's advanced R&D team. He is one of the original members of the GitHub Copilot team, for which he led quality measurement and improvement. He led the Copilot for Docs project, an early retrieval augmented generation system that can answer questions about private technical documentation. As I mentioned earlier, currently he leads the Copilot Workspace project, an agentic system that helps developers solve issues and address feature requests across the entire source code repository. Without further ado, Eddie, take it away.
All right. Thank you for the introduction, Rahul. Let me put my slides up. All right. So once again, my name is Eddie Aftandilian. I'm a principal researcher in GitHub Next, and today I'll be sharing some lessons that we've learned from building GitHub Copilots. AI developer tools are changing the way that we write software, and GitHub Copilot was one of the first such tools. It launched as a technical preview, essentially a closed beta, in June 2021, and today it has 1.8 million paying users, and 50% of those users' code is written by Copilot. Other companies, such as Google, report similar proportions of AI-generated code for their comparable AI code completion tools. This is only going to increase as the next generation of tools comes online. These are tools that approach the problem at a higher level. For example, completing an entire development task as opposed to completing a line of code or a function. These are tools like Copilot Workspace, which our team works on, Devin, Cursor, and so on. So in GitHub Next, we're a research or advanced R&D team within GitHub. We created the original GitHub Copilot in collaboration with OpenAI. And since then, we've created, in addition, something called Copilot X, which was a bundle of tools, including Copilot for Docs, and then most recently, Copilot Workspace. Along the way to these projects that sort of achieved escape velocity, we've also tried a bunch of stuff that didn't succeed. And so we've learned a lot from working on AI developer tools for the past 4 years. And today I want to share some of those lessons with you so that everyone can build great AI developer tools. I'm here representing the work of an amazing team. We currently have 18 people in GitHub Next. We have a mix of backgrounds and skill sets. We have front-end developers, back-end developers, machine learning researchers, programming languages researchers, user researchers, and so on. And it takes this diverse mix of skill sets to build new AI developer tools. So I want to share these lessons that we've learned. I've organized them into 2 categories: organizational lessons and technical lessons. So I'll talk about those, and then I'll recap in a conclusion. So first, I want to talk about some of the organizational lessons that we've learned. Setting up a team to do this kind of innovation work is quite difficult, but having the right organizational setup is critical to making it work. The first lesson is to think big. Being a research team within a big company is a precarious job. You're different from all the other teams. You're not delivering immediate value to an existing product, like a product or engineering team. And what you work on is risky, and much of what you try is going to fail. And so for this type of team to succeed, you need to bet on things that have the potential to deliver asymmetric value far beyond the effort required. Now, you might ask, is it realistic for a small team to think big? It's more realistic than you might think. And here I wanted to share the example of the original Copilot. When original Copilot was introduced in June 2021, there were fewer than 10 people on the team. One of the great things about software is that a small team of great people can build something with huge impact. And this is what I meant by asymmetric value on the previous slide. In addition, building an ambitious new thing can actually be easier to do organizationally than shipping an incremental improvement to an existing product. If you're trying to get a new feature into an existing product, there's a product team you have to interface with. You have to convince them that they want the thing that you're building. And if you build it and try to hand it over to them, they might balk because you're treading on their turf. You'll run into all the standard problems of tech transfer that industry research teams struggle with. But if you're building something totally new, then there's no team whose turf you're treading on, and you don't have to get their buy-in. We call this non-adjacency, and it's a core principle in Next. Does our idea represent an incremental enhancement that GitHub engineering would naturally do at some point? Or is it a fundamental rethinking of a problem that we are uniquely positioned to solve? We want our projects to fall into the second category. Back when we created Copilot, GitHub wasn't building IDE extensions and wasn't working on code completion, and this made it easier to make the case to launch this project. The second organizational lesson is to deliver tangible results frequently. If you're thinking big, it can be tempting to talk about multi-year time horizons. It's okay to have a long-term vision and an overarching plan, but you need to drop off useful things regularly, or it's going to look like you're doing nothing. And I wanted to share an example from our previous work on neural retrieval. In late 2022, we built a homegrown vector database to experiment with. Retrieval was a hot topic in the ML literature, and we wanted to see what it might be good for. So we first used it to explore natural language code search with a deliverable of a live demo at the GitHub Universe conference in October 2022. While this demoed well, the quality of the search results wasn't good enough for a real product, so we moved on to another application. The next thing we tried was using it to customize Copilot for private code bases. Because Copilot uses standard models that were trained on public code, they're not aware of a company's private code, internal APIs, custom programming languages, and so on. And so we were looking for a solution to improve quality on these private code bases. One way to do this is to index the private code base and store snippets in a vector database. And then as the user is typing, you query the database for similar code and inject it into the prompt. So we implemented this and we ran an offline evaluation and got a very positive result. But when we ran an online A/B test in Copilot, we didn't see any improvement in our key metrics. And we had another application for retrieval. So we handed this result in our code to the Copilot team and moved on. And by this time, ChatGPT had been released, and everyone was excited by chat. We realized that you could use retrieved snippets to ground an LLM chatbot in high-quality official documentation. We also realized that you could retrieve from private documentation as well as code to customize the chatbot for a specific company. So we refocused on retrieval-augmented chat, which turned into Copilot for Docs, which launches a tech preview in March 2023 as part of Copilot X. With this retrieval work, we were able to deliver 3 useful things, each taking a few months along the theme of investigating neural retrieval. The next lesson is to create urgency via deadlines. Setting deadlines focuses the team, forces you to make hard decisions, and great teams will rise to the challenge. These have to be real deadlines with an external commitment. People are smart and they will see through fake deadlines. The academic equivalent of this is committing to a paper deadline, and I'm sure you've all seen how much progress you can make in the week before a paper deadline. You do need to be protective of team health. The team cannot always be crunching. You need to balance these intense times with less intense times when the team has room to explore new ideas. And here I wanted to share the example again of Copilot for Docs. So as I mentioned, we had this vector database lying around. So we could build this demo of a chatbot grounded in private documentation very quickly. So we built that demo, we showed it around, and we were immediately asked, why haven't you shipped this yet? Could you have it ready for technical preview in 8 weeks? This was a very aggressive deadline. So I went back, I discussed it with the team, and we decided to go for it. Once we made that decision, it became a sprint. We couldn't argue about stuff for even a couple days. We had to make quick decisions and push forward. And it was fun to rally towards something big. And even though it was intense, the people who worked on Copilot for Docs will tell you that it's the most fun that they've had in Next. Next lesson is to be disciplined in project selection and continuation. Next aims for an 80% failure rate because otherwise we're not being ambitious enough. And so this means that most projects are going to have to end before they reach their goals. It's tempting to let stagnating projects continue in the hope that they'll unstick themselves or to avoid conflict. And in fact, many of these projects are not really stagnating. They're progressing, but just not fast enough or easily enough. Maybe they've hit a roadblock that's solvable with enough effort, but there's an opportunity cost to that. What are you not working on because you're working on this? And the opportunity cost is especially high in the LLM era when the models are improving exponentially. Also, the longer a project goes on, the more painful it is to stop it. If you've been working on something for a year, it's going to hurt much more if you have to stop that project than if you've only worked on it for a few months. Here's an example of a project that didn't continue, SpecLang. SpecLang was very ambitious. It explored whether you could write a natural language specification of a whole application and have an LLM compile it to code. The core idea was that the natural language should be the source of truth, not the code. As we worked on this, we ran into some hard problems. First, it's very difficult to iterate when natural language is the source of truth. One of the principles of SpecLang is that you shouldn't need anything beyond the natural language spec to compile the same code every time. But in practice, it's really hard to specify an entire application in that level of detail, not to mention dealing with LLM non-determinism. You might get something close to what you want on the first try, but then you can't just adjust one part of the application via this interaction. Second, it's just hard to generate a full, real application from scratch. It's hard to specify how you want it to work. It's hard to break it down into components, and so on. As this project grappled with these hard problems, other projects sprung up that needed help. And so, reluctantly, we paused SpecLang. And SpecLang didn't fail. Its core ideas influenced the rest of Next and led to the creation of Copilot Workspace, which I'll discuss in just a minute. The final organizational lesson I want to share is to beware of long-term project ownership. As a research team, your job is to invent new things. Time that you spend maintaining things that you've already built is time that you're not spending building new things. My teammate, Idan Gazit, has a saying, "You can't go exploring if you're carrying baggage." If you've ever been in the situation of trying to maintain an existing project while building a new thing, you know how hard this is. It's very difficult to justify spending time on something new and speculative when you have real users who are running into bugs in your existing thing or who have feature requests that you know will improve their experience. But as a research team, you have to spend time on the new stuff because that's your job. And so it's very important that you not hang on to projects for too long. You need to get these projects to a point where they can stand on their own and then hand them off to a product team to own long term. With original Copilot, this was a long process. Those of us who had created Copilot in Next went on loan into GitHub Engineering to seed and grow the new Copilot team. We helped get Copilot to general availability. We hired people who could take over our work, and we worked on knowledge transfer for almost a year to help build a healthy team that could own Copilot long term. Then we came back to Next and started working on new projects like Copilot Workspace. Next, I'd like to talk about some of the technical lessons that we've learned. The first lesson is that UX is critical, not just in AI developer tools, but in any developer tool. In the programming languages and software engineering communities, we have a long history of building really cool, innovative, useful tools that no one uses. Some examples, refactoring tools. So refactoring tools are broadly deployed, but they're underutilized. There are lots of cool refactorings that your IDE probably supports that you've never clicked on. And in fact, there's a line of research in the software engineering community trying to understand exactly why people don't use refactoring tools. Static analysis tools are another example. So static analysis is capable of finding like really complicated deep bugs, but by and large, it's not deployed broadly. The only types of static analysis that are broadly deployed are lightweight static analyses like linters. Another example are program verification or formal verification tools. These are definitely not applied broadly, despite their potential to reduce serious bugs in software. Even debugging tools, like using a debugger, you would be surprised at how many developers only do printf debugging. They don't use a debugging tool. And this list goes on and on. And I think this is because we haven't found the right UX to make these usable by real developers. And usually the people building the tools don't have UI expertise to find that right UX. But getting the UX right is the difference between success and failure. And so I wanted to talk through the evolution of the Copilot Workspace UI. Copilot Workspace aims to help a developer solve an entire development task, such as a feature request or bug report. It takes in a development task as input, finds the right places in a repo to address it, and then modifies the code. This is what the first prototype of Copilot Workspace looked like. It was an experiment by one of our team members, Don Syme. He had been inspired by SpecLang, but where SpecLang wanted the natural language to be the source of truth, Don wanted to explore keeping code as the source of truth, but enabling the user to modify it by editing a generated natural language specification. He called it extract, edit, apply. The user would first extract a specification of the code in a repo with respect to some topic. Here it's called the pivot. Then edit that specification, and then apply that edit to the code to update it in the way desired by the user. Don is brilliant, but he is not a front-end developer. And so you can see that this is rough, but it gets the idea across. And we've kept the core flow of extracting a specification and now a plan, and letting the user edit those and then apply or implement the changes in the code. This is the first publicly shown version of Copilot Workspace. It was demoed at GitHub Universe in October 2023. At this point, we had brought on our first front-end developer, Cole Bemis, and he totally revamped Copilot Workspace, and it looked amazing. Cole had previously worked on GitHub's design system, Primer, and you can see his fingerprints on this. It's now consistent with GitHub's design language, and it looks like a real product. After Universe, we brought on a second front-end developer, Turkel Gervig, and he revised the left-hand side with a timeline view. This makes it clear how you're supposed to progress through the flow. You start with the issue, you proceed to the specification, you generate a plan, and then you implement the code changes. This version has lasted the longest, from around March 2024 until very recently. And this is the latest UI revamp, which is an experiment that our users can opt into. We heard feedback from our users that they wanted help from Copilot Workspace before starting to implement. Often you might have an issue where you don't actually know how to solve it, and users want to brainstorm possible approaches with the AI in the context of that issue and that repo. And so this version focuses on the brainstorming side of using Copilot Workspace. You'll note that it removes the spec and plan. This is a big change, and we want to see how users receive it before making it the default. But early feedback is very positive. We spent a lot of time and effort on the UX of Copilot Workspace, and we believe that having a well-designed and polished UX is critical to making it something our users love to use. The next technical lesson is to build a prototype ASAP. As researchers, our instinct is to run benchmarks and quantify things. But feel is actually very important when building developer tools. And to get a feel for a tool, you have to build a prototype and use it. Also, a prototype is far more convincing to decision makers than benchmarks. And I want to share an example here from a previous job. I started a project called Fixbot with the aim of automatically repairing code that doesn't compile, using a model trained on source code edits. This was before LLMs, and so we had to train our own model to do this. So we started by collecting a giant data set and training that model, and then computing the fraction of failed builds we could fix. We could map that to developer time and show huge potential productivity improvements. But my management wasn't convinced, and it took us years to do all this work. If I could go back, I would do the least amount of work necessary to build a prototype that we could show to the decision makers, let them use, and so on. A usable prototype is much more convincing than charts and graphs, even at a data-driven company. In addition, having a usable prototype lets you test your assumptions. In Fixbot, we had some assumptions that made the project significantly more complex. For example, we believed we couldn't show fixes that wouldn't compile to developers. And so we did a lot of work to implement speculative builds to verify that the fixes would build. But if we had had a prototype, we could have just tried it, using it before we built that feature. And maybe the feature wouldn't have been necessary. Or maybe we could find a UI that lowers the cost of incorrect suggestions. The next lesson is to do the simplest thing first. As researchers, one of the mistakes we make is valuing difficulty or novelty when really we should celebrate simple solutions to hard problems. This is doubly true in the LLM era. If you can solve a problem purely through prompting an off-the-shelf model, you should do that. You should only move to more complex solutions if you absolutely have to. And it's surprising how many problems you can solve with simple approaches. And here I wanted to share an example of a Copilot feature called neighboring tabs. In the early Copilot days, we would send context from only the current file that you're editing to the model. But we believe that context from other files in the repo could be useful as well. So we implemented the simplest possible form of this, where we looked at other files that were open in the editor, did a very basic textual similarity match, and then inlined the relevant code into the prompt. What we did not do was spend months discussing this, over-designing it, training embedding models, setting up a client-side vector database, and so on. When we ran the A/B test, the result was striking. The improvement was comparable to the improvement we got from switching to a newer generation model. It was the single largest improvement we've ever gotten through prompting. And while we had a bunch of work planned to make this feature better, we never did it because the basic implementation worked well enough and there were other lower hanging fruit to pick. The next lesson is to build an evaluation suite. I mentioned earlier that feel is important, but quality is also important. In order to make decisions about model choice, prompting strategies, and so on, you need some way to measure quality. Your evaluation doesn't need to be perfect, but it does need to give you some signal. And here, the example I want to share is the offline evaluation harness that we built for original Copilot. This offline evaluation harness would use real open source repos. We would clone those repos, we would install their dependencies, we would figure out how to run their tests, and then run those tests with coverage enabled. Then we would look at the functions under test, find functions with good coverage, and then we would select those as targets for synthesis. And then we would blank out the function bodies of these targets. We'd ask Copilot to regenerate the function, and then we would rerun the tests to see if they pass. Now, the Copilot offline harness was limited. It only supported 2 programming languages, Python and JavaScript, and it only did full function synthesis, whereas deployed Copilot does line completions, does block completions, does full functions. And so, it wasn't perfect, but it gave us enough signal to make decisions until we had enough users to do A/B testing. The next lesson is don't over-index on cost. We're in an era of exponential improvements in LLMs. This means that costs have been quickly going down and will continue to do so. And so we shouldn't prematurely declare projects too expensive. Instead, we should focus on delivering the most value to the user and assuming that exponentially decreasing costs will make it financially viable. When we built Copilot, there were existing competitors, but they were all using small local models, presumably for cost reasons. With Copilot, we were aiming for much higher quality, which required a large cloud-hosted model. It would have been easy to just decide this was financially infeasible and kill the project. But instead, we focused on building the best tool we could and getting users to love it. And it succeeded. Over time, the models we use to power Copilot have gotten smaller and faster while quality has improved. We saw a similar thing with Copilot Workspace. When we started the project, we were using the preview version of GPT-4, which was terribly slow and expensive. But then GPT-4 Turbo came along, which was much faster and cheaper. And now we have GPT-4o, which is quite fast and quite cheap by comparison. The next lesson is to keep an eye on the literature. The machine learning literature moves super fast, and it can be very hard to keep up with. The models are improving exponentially. If you pay some attention to the literature, probably filtered through something like Twitter or X or Mastodon or wherever you go for your discussion about these papers, it can be useful to see what new technologies people are excited about. And sometimes you want to make a bet about how you think things are going to evolve and start moving in that direction before everyone else. And the example here, again, is retrieval. Back in 2022, we were reading papers about retrieval-enhanced models, and it seemed like this could be an interesting solution to the problem of adding additional information to an LLM. So we built a simple vector database to experiment with, and that turned out to be the foundation of Copilot for Docs, which we were able to build super quickly because we already had that core technology in place. And the next lesson I wanted to share is to dog food intensively. Dog fooding refers to the practice of using the things you're building. It comes from the phrase, eat your own dog food. And surprisingly, a lot of people don't do this, or they disregard the dog food feedback when it's inconvenient for them. In Next, we dog food intensively, and we take the feedback seriously. It often results in substantial changes to the things we're building. And I'd like to show the example here of Copilot NES, or Next Edit Suggestions. Copilot NES is a current project that aims to take AI code completion to the next level. Original Copilot suggests code where the user is typing and only takes into account the current state of the file. Copilot NES takes into account the sequence of edits the user has made and predicts the likely next one. This edit doesn't have to be at the cursor. It can be somewhere else in the current file. For example, suppose I add a new parameter to a function declaration. Most likely, my next edits are going to be editing the call sites to pass that new argument. NES will suggest those edits away from the cursor. At the beginning of the project, we had a strong belief about how we should present those diffs, with strike-through text and a replacement in light-colored text, or ghost text, like the original Copilot. When we started dogfooding it, however, we found that when the ghost text appeared, it would cause text later in the file to shift around in a very distracting way. And our dogfooders reported that it was very irritating to have their screen shifting around like that. So we reluctantly implemented a side-by-side diff view, and it was immediately obvious that this UI was better. The person who had been most opposed to it quickly admitted he had been wrong. And now it's time to shift gears and wrap up. If you take away only 3 lessons from this talk, I want them to be, first, think big. Don't settle for incremental improvements. LLMs are able to solve problems that were previously impossible, and our job is to figure out how to make those capabilities really useful to developers. Second, UX is critical. Building a great developer tool is not just about the core technology, but also about how easy and fun it is to use. Don't overlook this critical aspect of building AI developer tools. And third, dog food intensively. You really need to use the things you're building, and you really need to listen to the feedback and address it. Thank you for coming to my talk, and I'm happy to take questions.
All right, thank you, Eddie. And now we'll move on to the questions and answers session of the talk. We have a lot of time left. So if you have any burning questions, please type them in the question and answers tab, and we'll try to get to most of them in this session. All right. I guess first let's get to some of the regular questions or the straightforward ones, or maybe not so straightforward ones. Somebody asks that, is Copilot is our assistant, or is it our competitor? Or another flavor of the same question is, do you think, or what do you think we will ever be at a level where machines will develop the code all by itself? Decreasing dependency on software developers will ever reach to zero?
First of all, we're very far from that point right now, but the models are improving exponentially, and who knows what's coming. Maybe we'll have AGI, maybe we won't, who knows? My personal opinion here is that there's a lot of software that's not just about writing the code, right? So it's about figuring out what should we build, or what, if you have a customer asking for something, what do they actually want as opposed to what they're asking for, right? There's a skill set here in sort of eliciting the right requirements and figuring out what to build. In addition, so far with, the models that we have access to now, it's very difficult to scaffold an entire substantial application. So it's not hard to have a model build like a small, one file application or a few file application. But, when you get into hundreds of files or thousands of files with many components, it's not clear how to do that. And I think it's going to require substantial work. I'm guessing that there will be some class of software engineering task in the near future that models will be able to handle, pretty much on their own. But I think there's going to be some class of harder problems, system design problems, and these kinds of things where, a human software developer with experience and intuition is still going to be needed.
Cool. All right. The next most burning question appears to be, where did the 80% project fail target result come from?
That actually predates me. And in fact, we've had arguments within the team about whether that's a good idea. So the flip side of this, which I kind of alluded to in the talk, is that it's pretty painful when 80% of the things that you work on fail. I talked about being disciplined in project selection and continuation, and I talked about how it hurts when something that you worked on, is not going to continue. I think Rahul and I can both point to examples there where we've worked on things that we were very excited about, and then they just weren't ready yet. So I mean, I don't know where that number came from, but in our experience, it seems about right. Like I would say actually about 4 out of 5 things we try fails. And the key here is to like, you know, don't spend too much time on any given thing. Like if something is not working or um it's not sort of immediately obvious that it's going to work, maybe you should consider going in and working on something else. Because with the LLMs, like I said, there are new capabilities every day. There are new things to explore. And if you're sort of continuing on a path that is difficult or isn't working out, you're not working on some other thing that could pan out.
Absolutely. And I can attest to that. Like, yes, I have worked on projects with Eddie that have failed. I've worked on independent projects. Failed is a strong term, but did not
Yeah.
get to the final out.
And I think the other observation there that's been fun is that the projects, like I said, I don't think they've failed. They've sort of gone on to influence other projects, and you can see this sort of strand of like research or idea like flowing through Next. And spec which I showed like directly influenced Copilot Workspace. Um, you know, uh, some of these things also might just have been a case where we were too early, right? So maybe we want to come back to some of these ideas as the technology improves. Like for example, Copilot Voice. Today we have, or just yesterday, OpenAI announced this real-time API that lets you do speech to speech in very low latency. And latency was one of the core problems with Copilot Voice. So maybe it's time to revisit that now that we have new technology that might make it feasible.
All right. The next question, most upvoted question is, if Copilot is entirely dependent on GPT-4o, what are the specific advantages over directly using GPT-4o? And I guess like you touched upon this question in the previous response, but.
So Copilot, I mean, I guess you could have an extension that makes calls, but there are technical reasons that you can't do this. For example, like GPT-4o. So like fundamentally, like original Copilot is code completion. It's a completion task, right? Where it's basically exactly what the models are pre-trained to do, right? So the models are pre-trained, they're given sort of a prefix of some text file or source code file, and they predict the next token. And that's basically exactly what you're doing in Copilot. GPT-4o off the shelf doesn't provide that capability anymore. It only provides a chat interface. And so now, are you going to sort of compose your code completion problem as a chat? Like that doesn't seem very ergonomic. In addition, we do a lot of prompt engineering behind the scenes to make the quality very good. So like the obvious way that you build something like this is you take the prefix of the file up to the cursor and you give that to the model and you ask it to predict the next thing. But we do prompt crafting where we pull stuff from other files, and we do more than just the neighboring tabs that I described. There are actually like quite a number of things that are all supported by A/B testing, and we can show how to positive improvement in our key metrics.
Cool. Somewhat related questions, or there are a few other comments around this. Can you elaborate on whether or how you preclude hallucinations from the user's resulting artifacts?
Yeah, so in the context of original Copilot, the best thing that you can do here is provide the right context to the model so it doesn't hallucinate, right? So one of the common hallucinations that you do see with original Copilot is it hallucinates like a function on a type that doesn't actually exist or something like that. So there you can do things like, extract the interface of that type and inline it into the prompt so the model can see exactly what the types are on that thing. There are other sort of fancier techniques that aren't deployed, like constrained decoding and these kinds of things that you can do. But to be clear, Copilot does hallucinate. And in the end, the code has to run. And if it hallucinates a function that doesn't exist, your editor or your compiler is going to complain at you. This is actually one of those like early assumptions that I personally would have had if I hadn't been able to just try Copilot. I would have assumed that like having Copilot generate completions that didn't compile would just be a non-starter. Like that people would be really upset if that happened. But when I actually used it as a prototype, it didn't bother me. It doesn't happen all that often because the models are pretty good. And in Copilot, I talked about the importance of UI. In Copilot, the UI is very well suited to lowering the cost of incorrect suggestions, right? So in original Copilot, I'm typing, I pause, a completion pops up as ghost text. If I don't like it, I just type the next character that I was going to type anyway. And so there's almost a zero cost to me getting a suggestion that's incorrect. And it's very easy also for me to guide the solution to like what I'm looking for by just typing the next character that I was going to type. And so, yeah, I guess a sort of a roundabout answer to the question of like, it does hallucinate. We try to provide it the right context to reduce the hallucination, but it still hallucinates. But also users don't seem generally that bothered by it.
Yes. And I hope this also answers one of the questions that was raised when say that a fix that doesn't compile in response to your story about a fixbot.
Yeah, I mean, I think FixBot was a different case because it was not the LLM era, so the models were less capable, and it might have been true, but we never actually validated that assumption, and it was an assumption that cost us probably 3 months of engineering work to build the speculative build, and it would have been nice if we had just tested that quickly before investing that amount of time and effort.
Right. Right. Changing gears, we have a question from an anonymous attendee who asks, they teach computer programming to high school students. How do you, as one who works in depth with the Copilot and other AI technologies, recommend that they integrate these technologies into their classroom to prepare the students to the best to maximize the technology, but also learn the fundamentals in programming?
Yeah, that's a great question. So one thing that I've found with using the chatbot style tools like ChatGPT or Copilot Chat is that they actually make it they're almost like a personalized tutor, right? So like if I don't understand some concept, I can go back and forth with ChatGPT in a way that I would probably be embarrassed to do with a real human. So like a concrete example of this from my like own technical life. Recently, I was interested in understanding how temperature sampling in LLMs work, right? And I'm a researcher. I work on this stuff. I found a paper that had like an equation about like how do you actually implement temperature sampling. I couldn't make heads or tails of this equation. And I copied and pasted it into ChatGPT. And then, ChatGPT, I can just go back and forth and ask, okay, what does theta mean here? Like, where does it come from? And then interestingly, like often with the way we teach things, we sort of simplify them in the hopes of like making it more palatable to the students. But actually, in reality, you kind of need to know like how it works in reality for you to fully understand it. And for this particular equation, there, if temperature goes to zero, you end up with a divide by zero. And I was like, what does that mean? And if I were trying to learn this on my own, like I probably wouldn't, or in a class, I probably wouldn't be willing to like ask that kind of dumb question of to the professor or teacher. But I could ask ChatGPT, and it was a good question actually, because ChatGPT is like, oh, that's just a special case. When you actually implement this, you do it this way. And I found that super helpful. So, I don't really know what kids should be learning in terms of programming these days. I think it is important to be able to read code and understand it. I think reading code is maybe a more important skill than it was in the pre-LLM age. And maybe actually writing the code is less important. I know that personally, I spend a lot of time, like reading the code that Copilot suggests for me, trying to make sure it does what I want, trying to understand it. Um, and being able to quickly validate these LLM suggestions is important. But I also think that there's potential here for people to be able to learn things at a deeper level than they were able to, in the sort of classic classroom way.
Absolutely. Uh, and switching from classroom to more industrial setting, someone asked that they're leading a project to adopt Copilot in their company, and there are many variations of these questions. And the question is how to measure real-world productivity gains. And a few of these folks have said that they are familiar with our CSEM paper.
Yeah. So I have to say, like the real authority on this would be the Copilot team at this point, but I can talk about some of the work that Next did, like early work to evaluate the productivity impact of Copilot. Um, so there were sort of two lines of work here. One was the work that was in the CACM paper um, about neural. I forget what we titled it. Something about like productivity assessment of neural code completion. I think that might have been the workshop title or something. But anyway, with that paper, the goal there was I mentioned the importance of A/B testing once you have users to figure out, is a change that you're making positive or negative. Um, and so that the problem there is that, we collect telemetry on users, and we have, I don't know, potentially like 100 metrics that we could pull out of the telemetry, and it's not clear which of those are actually important and which ones are not. And really, when you're running one of these A/B tests, you want to limit it to like just a handful of key metrics, maybe like 3 key metrics, and use those to guide your decision. Because any change you make is going to perturb the project in some way. There's going to be some metrics that go down and some go up, and you're going to have to be able to make sense of that. So in that work, we sort of cross-referenced telemetry data, so hard quantitative data on things like acceptance rate, what fraction of suggestions the user accepts, things like persistence in the code. So, if let's say the user does accept, but then they edit the suggestion quite a lot, is that bad? And how bad is it? Things like the amount of code contributed by Copilot, latency, things like this. So we sort of correlated that against qualitative survey feedback from a set of like a number of users. Like I can't remember the number now, but it was like a good number of users. Um, and on that survey, we asked for sort of self-reported assessments of productivity. Like, do you feel more in the flow? Do you feel like you're more productive? And so on. And these come out of like a well-known framework for productivity assessment called SPACE that comes from Microsoft Research. And so from that, we were able to find the key metrics that correlate most strongly with users' perceived, like self-reported productivity. And from that, we found that acceptance rate is most strongly correlated with users' perceived productivity. And like I said, acceptance rate is the fraction of completions that the user accepts versus rejects. It was kind of surprising to us. Like we actually thought that persistence in the code would be a better predictor because, if you accept something and then don't have to edit it, that seems like a stronger signal than just whether you accepted it in the first place. And so our hypothesis or explanation for why that is that when Copilot suggests something for you, it's often helpful even if it isn't perfectly right, because it gives you kind of a sketch or a scaffold, and then you can go in and edit it to do exactly what you want. The other line of sort of productivity assessment that was done within our team was like sort of a lab study where I think we had around 100 professional developers, and we gave them like a standard programming task. And I believe the task was to implement an HTTP server. So this is it's a real world-ish task, but it's also synthetic, right? It's not actually acting in like a real code base. They were given tests that they could run as acceptance criteria. So their goal is, they're given a GitHub repo and they have to get all the tests to pass. And we time them. We see how many of them complete the task successfully, get all the tests to pass, and how long it took them to get to that point. So we gave half of the users Copilot, and then half of the users didn't have access to Copilot. And we found that the users who had access to Copilot completed the task 55% faster than the users who didn't have Copilot. Now, there are a bunch of caveats to that study. The biggest one being that, it is a somewhat synthetic study, and it's not guaranteed that that result is going to translate to real programming tasks that people do every day. But those are kind of the two ways. I believe that nowadays customers have the ability to see metrics like acceptance rate and so on, the same ones that we use to decide A/B testing. But I'm actually not totally sure on that, and I would ask the product folks if basically that same question, because it's a question I think they get a lot.
Right. Yeah. So the next question is a little bit interesting, and somebody asked, when do you think Copilot would be able to build reliably ready to run unit tests for large scale applications with tens of thousands of classes requiring huge amounts of text to be in memory of LLM?
That's a good question. So I mentioned earlier about sort of taking bets on where you think things are going, and context windows are one of these things. So for those who aren't familiar with the underlying LLM technology, these models have what they call a context window, and this is the amount of data that you can put in your prompt and how much data that the model is going to output, right? So it's a combined input and output, has to fit within some fixed window. When we started original Copilot, I believe our context window was very small, like 2K tokens. But over the past few years, context windows have been like an area of an intense research and serious improvement. So currently, GPT-4o has a 128K token window, and other models have million token windows. This is also like a token is like rule of thumb, maybe like 3 bytes. So you could say like with a million token context window, you can input and output combined about 3 megabytes worth of data. So that's still not enough, to put in a giant project. But my guess is that within like a year or two, we are going to have models with like, I don't know, a 10 million token context window, and it's going to start to become possible to put all of this data into the context window. The models are still going to have to improve on picking. So models, one of the issues with these long context windows is the models are also still not great at picking like a needle in the haystack type problem of like, I need this specific bit of data from, somewhere in the middle of this giant prompt. But again, I expect the model people are working on this stuff, and I expect them to make fast progress. In terms of like practically what you can do today, the systems that try to do this, and these are systems like Workspace, Copilot Workspace, we try to find files that are relevant. So like, suppose you want to generate like a unit test file for, some particular class or something, right? Probably most of what you need is just the original class. And then, if there is an existing test file, you want that content of that file. And that may not be that much data and probably fits in your context window. So the trick here becomes finding the right context and giving that context to the model so that it has everything that it needs to solve the problem. And that's an area of sort of ongoing research, more on the sort of AI developer tool side. But also with that, I expect that we're going to get better at that over time. And eventually, like you will be able to do things like this. I don't think you're ever going to get to a point where you're just going to like accept, well, okay, I shouldn't say never, but it seems unlikely to me that you're going, as the owner of this project, you're going to just blindly accept or let the model like write tests for you and not look them over, right? Because you wouldn't do that with a human developer either. Like I hope you're all, have a code review process and you're reviewing the code that your colleagues are submitting. And it's not because you don't trust them, but it's useful to have a second set of eyes on things. Maybe you missed something. If anything, someone else on the project needs to understand what was done there, so that you have some backup in case this person decides to leave the team, leave the project, goes to work on something else, or so on. So I guess kind of a two-pronged answer. Like I th I think like tests are, it's pretty plausible that we'll be able to generate pretty good tests at some point. Um, I don't know that you're going to want to just sort of happily accept the tests that a model generates without looking them over and reviewing them the same way you would review a human PR.
Cool. We are coming towards the end of the session, but let me take last two questions. The so this one is interesting, and this one is very close to my heart as well. Do developers not use refactoring tools because developers don't really understand refactoring? Are all of these refactoring tools do 100% correct refactorings, or does it make some mistakes? Could the problem be other than just the UX? Or in
Mm.
the similar vein, like, why don't developers use tools?
So I think at least for the case of refactoring tools, I really think it is UX because a lot of the refactorings aren't discoverable, right? You've got to dig through like 6 layers of menus. You kind of have to know like which refactorings are available. And at least, personally, like I use, rename symbol all the time. I use maybe like extract method occasionally. And then there are a bunch of like fancy ones that I never use because I just never think of them. Um, my best guess is that, yeah, it is UI, at least in the case of refactoring tools. And if you could build a UI that lets you, you know, gives these refactorings in context. So like, I talked about Copilot next edit suggestions, right? And I talked about this like adding an argument to a function, and that is a standard refactoring. If you can sort of teach the user in context, not in a clippy kind of way, but like it looks like you're doing a refactoring. Do you want me to finish this for you? But in a way that is not as annoying as Clippy. Uh, I think you'd get a lot more usage of these features. I think people would actually use them if they were discoverable. And so, yeah, for refactoring tools specifically, I do think it's a UI problem, and I think it's something where, like in the AI dev tool age, I think we can solve this and probably generalize it as well, in that like models are more flexible. They're not limited to the sort of canned refactorings that the people building the refactorings have thought of. And so this is actually an area where I'm pretty excited. I think we'll make progress as these sort of next edit prediction type things come along.
Well, maybe we have 1 minute, but I like this question very much. How do you build a team of, so some variations of this question is, how do you build a team that you talked about for this R&D type?
That's a great question. So I think like a few things here. We hire more like a startup than like a big company for this team. So like we sort of we have our own sort of interview process that is like fairly different from your traditional like lead code style big tech company interviewing process. Our team specifically focuses on senior people. So, part of the idea is that we want people who are self-directed and also have, some intersection of like product judgment and the technical skills. So like, you know, sometimes you might get stuck on a technical problem that you can sort of get around via the right product decision, or maybe it's the wrong technical problem from the product perspective to focus on. Our team is small. So I mentioned that we're only 18 people, and that helps with sort of hiring the caliber of people that we want to. And then I think another thing that the managers on the team do is just maintain a good relationship with the community of people that we want to hire. So for me, it's often academics. That's why I'm here giving an ACM tech talk, and that's why I would go to conferences and such. And then for the more front-endy people, my counterpart over there spends a lot of time actually talking to people on Twitter and seeing who's doing exciting work and sort of proactively reaching out to them.
Cool. I'm afraid that we have run out of time, and there are many interesting questions that are still open. And hopefully we'll get to those questions in some manner, maybe async once we get the list of questions from the ACM. I would like to thank Eddie again for his informative presentation and insightful answers to many of the questions. And a very special thank to each of you for taking out time in your busy lives and attending and participating today. As I mentioned earlier, this talk was recorded and will be available online in a few days at learning.acm.org. You can find announcements of the upcoming interesting talks and other ACM activities at the same website, learning.acm.org and acm.org. Again, as a request, please fill out our quick survey where you can suggest future topics or speakers, which you should see on your screen in a moment. On behalf of ACM, Eddie, and myself, Rahul, thank you for joining us, and I hope you will join us again in the future. And with this, we conclude our talk.